Let's start working some problems from section 13.1 in the homework here. Let's look at 13.1, number 6. A, they ask us to do the following. Find the integral from 0 to pi, 2x cosine y plus sine x, and you're integrating with respect to x. Since you're doing that, you're holding what? Y as a constant here, so this is going to be fairly easy here. So just imagine if y is a constant, therefore cosine y is also a constant. So I'm essentially just using that as a multiplier, as a factor. Integrate 2x with respect to x, and you guys see that would be what? X squared, so I've got x squared cosine y. Okay, and here the integral of the sine of x is actually what? What's that antiderivative there? Yeah, don't forget it's minus cosine x. Okay, no point in adding c because this is a definite integral. We're going from 0 to pi. Okay, now that's what? I'm not going to be doing this forever, just keep it in context, but for a while here we'll go x equals 0 to x equals pi so we don't get mixed up. So let's see, we would have what? If x is pi, we would get pi squared cosine y minus the cosine of pi, okay, minus, let's evaluate this at what, 0. We can see we're going to get 0 right there, minus cosine of 0, okay. Let's see, so we would get pi squared cosine y. The cosine of pi is actually what? Negative 1. So the double negative there gives plus 1. Okay? I have a double negative here, so that gives a plus again. The cosine of 0 is 1. So we've actually got what? Pi squared cosine y plus 2. Box in your final answer. That's for part A. For part B, we want to do this. We're integrating from 0 to pi over 2. Integral from 0 to pi. 2x cosine y plus sine x dx dy. Now we notice here that this inner integral we just worked out, this is actually then the integral from 0 to pi over 2, pi squared cosine y plus 2. Okay, so that's that result there. dy, we need to integrate that. Let's see, what are we going to get here? Antiderivative of cosine y would just be the sine, wouldn't it? Plus, just use the power rule here. This is easy, 2y. Y is going from what? 0 to pi over 2. So let's do this evaluation here. We would get pi squared sine of pi over 2 plus 2 times pi over 2 minus the evaluation at 0. The sine of 0 is 0, so you guys see we're going to get 0 out of this and 0 out of this. And this whole thing boils down to, let's do a quick mental calculation here. We would get the sine of pi over 2 is 1, so times pi squared is pi squared. And then pi over 2 times 2 is pi, so we've got pi squared plus pi for our final answer to this particular problem. Alrighty. Okay, next let's take a look at problem number 8. Part A says we're integrating from y to y squared. Let's see, the integrand is x minus y. And we're integrating with respect to x first. Okay, so this is one of those partial integrations. Okay, this is going to be pretty easy here. Remember, we're holding y as constant. The integral of x with respect to x is 1/2 x squared from the power rule. Y is acting like a constant. I'll write x's before y's. So it's 1/2 x squared minus xy. Now here, let me emphasize, x is going from what? Y to y squared. Okay, so let's start evaluating that. Let's see, when I substitute y squared here for x, I would get 1/2 y squared squared, and then what? Y squared times y. Okay, that would be the first whole term in our difference here. Now I've got to evaluate what? X at y. So this would be 1/2 y squared minus y times y. Thus so. Okay, let's see what this simplifies to. This goes to what? 1/2 y to the 4th minus y cubed minus 1/2 y squared plus a y squared. Okay, let's maybe write this in descending order here. I've got 1/2 y to the 4th minus y cubed. Combining these like terms here, I've got plus 1/2 y squared. Let's box in our final answer here, and there we go. That's for part A. Now part B asks us to do the following. We're going to integrate from -1 to 1, the integral from y to y squared, x minus y, dx dy. Okay, now we just worked out what this inner integral is equal to. It's the result that's been boxed above. So in fact, we're going to integrate from -1 to 1, 1/2 y to the 4th minus y cubed plus 1/2 y squared dy. And we can see this is easy power rule problems here. So we've got what? 1/10 y to the 5th minus 1/4 y to the 4th plus 1/6 y cubed, and then y is going from what? -1 to 1. Okay. Okay, at 1 we're going to get what? Because of the nice easy value here, this is easy to evaluate. We're evaluating at 1. How about at -1? Because of the odd power there, we get a -1/10. We'd get what? -1/4. And then we get -1/6. So you can see the even part drops out. The even power drops out, but the odd powers get doubled here. Anyway, we get what? 2/10 plus 2/6. So we've got what? 1/5 plus 1/3, which is going to be 8/15. And there we are. So we are done. All right, let's do problem 10 now. In that same section, let's look at part A. We're integrating from 0 to x. 1 over 1 plus x squared dy. Okay. Now this is going to be very easy, right? Because what? X is acting like a constant with respect to y here. So 1 over 1 plus x squared is acting like a constant. So this is really, really very easy here. Okay, it's just, if you want to, imagine just bringing that whole integrand outside and you begin integrating dy. In any case, you can see it would be y over 1 plus x squared, and then x is, or y is going from what? 0 to x. I think you can do a quick mental calculation there and see we get x over 1 plus x squared. Let's box in that final answer and let's do part B. Part B then asks us to do what? We're integrating from 1 to 2, 0 to x. 1 over 1 plus x squared dy dx. Once again, we've already worked out the inner integral and we got the result above, x over 1 plus x squared, and that's what we'd be integrating with respect to x. You guys can see here what you might want to do is maybe use a u substitution. U equals 1 plus x squared. Differential changes in u would be 2x dx, like that. That means 1/2 du is x dx. Let's write an equal sign here. So we actually have a 1/2. We'll bring that out front. And then we've got what? Du here. Okay. And this is 1 over u. Okay. Let's see. X was going from 1 to 2. That means u is going from 1 plus 1 squared, which is 2, to what? 2. 1 plus 2 squared is 5. You guys can see this is going to be 1/2 the natural logarithm of the absolute value of u, going from what? 2 to 5. And that will be 1/2 the natural logarithm of 5 minus 1/2 the natural logarithm of 2. If you want to combine those, you could do something like this. 1/2 the natural logarithm of 5/2 thusly. Okay, so there it is. There we worked out a few problems in that section.